Today's lesson is on proportional and non-proportional relationships. Both of them are specific types of the linear function, but they just have some similarities but some differences. Before we start on the difference between a proportional and non-proportional relationship, I want to talk about slope and y-intercept. We're somewhat familiar with the general form of the linear equation y equals mx plus b. And if you remember, slope is referring to m, in which to find the slope it is the change in y divided by the change in x. And then the y-intercept is b, and it is the point 0, b on a graph. So whatever point matches up when x is 0, in other words, it's the point that crosses the x-axis. Or, I'm sorry, the y-axis. So you need to know about slope and y-intercept before we talk about the two kinds of relationships. So first, a proportional relationship is the same as a direct relationship. So in our last lesson we talked about a direct linear function that is the same as a proportional relationship. And then non-proportional is also referred to as an indirect. In a proportional relationship, the equation is y equals mx, or like you have seen, y equals kx. And then a non-proportional relationship is the full form y equals mx plus b. And the reason is, in a proportional relationship, the y-intercept always goes through the point 0, 0 at the origin. However, in an indirect or a non-proportional relationship, the y-intercept goes through any other point other than the origin. And in a proportional relationship, the reason it is called proportional is because when you take y divided by x in any point in a proportional relationship, that ratio is proportional. And then the opposite, obviously, is when you take y divided by x, it is not proportional. So that is the difference between a proportional and non-proportional relationship. Now we're going to graph two lines, one that is a proportional relationship and one is non-proportional. So the proportional relationship, we're going to look at the equation y equals negative 3/4 x. If it does not have a y-intercept listed, or it's a proportional relationship, that means the first point is at the origin. And then we use the slope, negative 3/4, to get our other points. And if you remember, you want to think rise over run is negative 3/4. So from the origin, we're going to rise negative 3. So that means go down 3. And then we always go to the right. So go to the right 4. Put our second dot and continue that pattern. Down 3, right 4. And then go back to the origin. We want to go backwards. Go up 3, left 4. And now we can connect the dots. So the biggest thing is, it goes to the point 0, 0. And then always double check that your slope is right. It went down 3/4. Alright, now let's graph a non-proportional relationship. Let's look at y equals 2x minus 4. This time, our graph is not going to go through the origin. It's going to start at our y-intercept of -4. So our first dot is now at -4. And our slope is 2. So if you want to think rise over run, let's write 2 as a fraction, 2 over 1. So we're going to rise 2, run 1. Go up 2 over 1. Up 2 over 1 and continue that pattern. And you can go backwards down to left 1. And then we can connect all of them for our line. So the y-intercept is at the point 0, -4, and then double check. You're going up 2, right 1 each time. Up 2, right 1. Now let's look at a table of values. For the proportional relationship, for my x values I have 0, 1, 2, and 3, and my y values 0, 9, 18, and 27. So one thing that you can look at and automatically know it's proportional is the fact that it has the point 0, 0, which means it will go through the origin. And the other thing that you want to check is this y divided by x. Is it proportional? And you always do this not including the 0, 0. So let's look at 9 divided by 1. Does it equal 18 divided by 2? It does. And does that equal 27 divided by 3? And it does. So therefore it's proportional. And my equation is y equals, divide all of these and you get 9, 9x. Which makes sense because the change in y divided by the change in x is 9, and then the y-intercept is 0, so there's my equation. Now let's look at a non-proportional relationship. For my x values, same thing, 0, 1, 2, and 3. And my y values, 4, 8, 12, and 16. So right away you can see that we do not have the point 0, 0. 0 matches up with a different number, therefore it does not go through the origin. And then also if you check by doing this y divided by x, does 8 divided by 1 equal 12 divided by 2? No, it does not, which once again does not equal 16 divided by 3. So y divided by x is not proportional, but it's still linear, because if you look at the change in y, it goes up by 4 each time, and then the change in x goes up by 1 each time. Therefore my slope is 4, so I have 4x, and then my y-intercept is the number that matches up with 0, which is also 4. So my equation here is 4x plus 4. And here are our last examples comparing proportional relationships with non-proportional relationships. So here are two real-world scenarios. The first one says that Marcos is a personal trainer at a gym. In addition to his salary, he receives a $45 bonus for each client that he sees. So, $45 bonus for each client that he sees. Let's create a table that represents this situation. We can look at clients and how his clients change. We want to look at how his pay changes. For one client, he gets $45. 2 clients, 90. 3 clients, 135. 4 clients, 180, and so on. If we do y divided by x, 45 divided by 1 equals 90 divided by 2 equals 135 divided by 3 and equals 180 divided by 4. So this is proportional, and it's increasing by $45 each time. So the equation is y equals 45x. In this next example, it says that Marielle is bowling with her friends. The table shows prices for renting a pair of shoes and bowling. Write an equation to represent the total price y if Marielle buys x games. So 2 games cost $7, 4 games $11.50, 6 $16, 8 $20.50. So let's first find the slope by doing the change in y divided by the change in x. So x is changing by 2 each time, and here it's increasing by 4.5. So change in y divided by change in x, we're looking at 4.5 divided by 2, which is 2.25. So 2.25x, that is my slope. We need to figure out what is the y-intercept. So we want to think about what would be on our price side of our table when it's 0 games. So if we, let's see, go backwards in our table, subtract 2 to get to 0, we would have to subtract 4.5 from 7, which is 2.5. So my y-intercept is 2.5. So here I have slope and y-intercept into a non-proportional equation. So there's the difference between proportional and non-proportional, and really one of them goes to the origin, the other does not, and that is the biggest difference between them. Good luck with the lesson.